Hope you guys are having a great day so far. Things going good? Yeah, good keynotes. So we're all developers. Well, most of us are developers. We write code. We build stuff. A lot of times we have deadlines. When we have deadlines, we have to make sure we get all the code ready in time. And a lot of times I feel really great when my code is ready the day before the deadline, or the day of the deadline sometimes. But when that happens, sometimes I start getting a little dejected because I'm like, uh-oh, now I have to get that code from my machine up into the internet. And is that easy? It should be, right? And what do we have to do to get there? Should it run the same on my machine as it does in the internet? Well, maybe, maybe not. So we have to think about all the concerns that we might have. For example, when I'm running as a developer in development mode, things run differently than when I run it in the cloud or on the internet. Because maybe I want it to be faster, more optimized. Having a 20 meg download locally isn't a big deal. Maybe having that on a mobile device is kind of a big deal, depending where you are, right? So all these kind of concerns start going through our head is how do we make sure we take the code that we know works on my machine and get it to work on all of your machines? So that's the goal of this talk here, to help enable all of you to figure out how we can do this optimization. And by the end of this talk, I hope you'll be there with me. So let's start with the first step. We have our code, it's written. We need to build Angular. So when we build Angular, luckily we have some great tools. And without great tools, things get a lot more complicated. We all know about the Angular CLI. We've got a great talk this week by Mike Brocky about this. And the CLI helps us do a lot of things. The thing it gets the most notoriety for is generating code, writing code, creating projects, creating classes, services, all these different things. So it creates the code for us running these commands like this, ng generate service, component, class, and it spits out the files. And it wires things up. And that's great. But in the life cycle of a project, you don't spend most of your time creating files. And that's not where most of the hard parts are. We can do this kind of work on our own. Love that it's there, but it's not the big reason I love the Angular CLI. I love it because there's other things that we want to do too. When it's time to build, they've taken care of all the things that we need to do to build our project. Now let's think about the use case for building. We don't build just because we have to. We build because of the development cycle. It's for the developer. ng build runs a development build. And think about what a developer wants when he or she builds. We write the code, we run it, we build it. We want to open it up in a browser, see mistakes or changes, go right back to the editor, make those changes, and see it again in the browser. That's the dev debug cycle. That's got to be fast. That scenario is for speed, so we can keep moving along and iterating. Some of you may remember the days when we were building things, and it would take minutes in between those. Not in Angular, but in the older days, back in early JavaScript. Or if you go way back to the VB days, or I started with COBOL, and we had to pay for our builds. Back then, wow, that's weird. So back then, we had to do all this stuff, and if you had to make sure that your code was right before you ran it and built it. Now we can get it and do this hundreds of times in a day. But when we're done, it puts it in a dist folder, and we go to production. We don't build for the developers. I know that's shocking, but we don't write code for other developers. We write code for an end-user experience. And for end users, it's a different scenario. In that case, we want to build for production. We want to optimize our builds. We use flags like prod and build optimizer. And you think about that experience, the experience they want is not the dev debug cycle. They want the fastest, most interactive use. Time to first byte on the browser or the mobile device. They want to be able to interact with it and move between different bundles, if we do lazy loading in the apps, really quickly. So these two different builds are built for different scenarios, different target audiences. If we look at the difference between what they do under the covers, this is just a synopsis. You have different environment files. We have to make sure that it runs locally or on other machines the way it's supposed to run. So in a prod build, we look at a different set of environments. We want cache busting in prod builds, so we don't have any caching for our end users when we redeploy. We use source maps for local, but not for production, so we can do debugging. We can extract our CSS. We get to uglify, minify, and AOTify. I just made that up. So AOT, right, ahead of time compilation that we have in Angular really helps speed things up for the end user. And we get some things like tree shaking that we can take advantage of, which gets rid of all the dead code. Not all of, but a lot of the dead code in your Angular applications. Why we do this? In a production build, we want it to get to be small. Smaller means faster. We want it to be small going across the wire, faster running inside of the browser. So let's take a look at how we can do this and analyze some of our builds as we use the Angular CLI. All of the code that you're going to see today is in a project called Angular Cosmos DB. And this app's just a simple little app that shows a list of heroes. I kind of like heroes. And this app here is going to run locally on my machine, and we're going to build it and see how big it is by default. So let's pop out to a terminal. There we go. And we'll go run ng build real quick. When we run this, it's going to go ahead and build the files for a development build. And we're going to see the different bundles it's going to create. It's going to take all of our code, put them into a couple files. And the two main ones I want to look at are main and vendor. If we look at the main file, that's code I wrote, 31K. Not too bad. Look at the vendor file, it's 2.3 meg. Not worrying about it right now locally, but that's not exactly ideal. And in some apps, you start pulling in third-party libraries, you can get up to 5, 10, 15 meg really quickly, depending upon what you're pulling in. But how do you figure out how to reduce file size? You can't just throw away the files. Well, you could, but your app probably wouldn't run. So the first thing we can do is go ahead and run a prod build. When we run a prod build, let's look at the difference that these files make. Now, prod's going to do a little bit more than we just did. It's going to try to shrink things down more, too. And it's also going to put in different file names for the cache busting. Once again, we'll look at the main file. We went from 31 to 17K. That's pretty good. Almost a 50% reduction of my code. Awesome. And then the vendor file went from 2.3 meg down to 300K. That's pretty darn good, isn't it? We lost 2 meg out of our code. So that's not so bad, but could we do better? What if you're not sure what's in your code? Can you look at more of it? Well, Angular can. So we can run the one command I can never spell, prod and then optimizer. This is a newer feature in the, see? I can't spell it. We need aliases. So we need to run this with the build optimizer. It will actually try to get rid of some of the dead code. It will examine my code to see, is there anything that maybe you're not actually using that I can toss to the side? Because let's face it, a lot of times we build projects and we write code, and later we get rid of it, but we don't entirely get rid of all the code. First thing we notice is the vendor file's gone. It's great. It threw out all the vendor files. Love you, Angular CLI. That's the first thought I had when I looked at it. It actually combines the vendor file with the main file. So now what you have to do is you look at the vendor file from the top, 313K, plus the main file. So you got about 330K. And then down below, the main file is now 265. So we shaved off like another 65K, if my math is correct, off this, by getting rid of code we're not using. That's pretty good. You think the more flags they add, we'll get down to 0 eventually, right? Just keep adding flags, guys. We love it. If we can get to a negative file size, then you know you win. All right, but how do you know what's in your code? One of the things I like to do is I look for some things that I've commonly run across, but how did I discover places I could even do more optimization? How many of you here use RxJS? A good portion of you, great. How many of you enjoy typing import RxJS add operator / at the end of it? Yeah, there was one guy who thought about raising his hand. It's fun to type all those things out. Is it, I always forget, is it add operator or is that operators, plural? Is it operator add? I don't know. I don't care. I just want the map operator. Well, when you have 10 of these in a file, you start putting 10 imports in there. Then you have other files, and you add those in there too. They get all over your app. So I see this happen a lot, and I admit I did this once. Let's just import RxJS / RX. I'm already using 10 to 20 of the operators in my app anyway. How many more could there possibly be? The app still runs, right? Let's go back up here, and let's just go to the prod build for a minute. We'll do it here. Actually, let me cancel that. We'll do a prod build, and I'm going to turn on source maps true, S&M true. Why am I turning on source maps? Because I want to explore the build, and when you do a production build, source maps are turned off. So we'll see what kind of a production build gets created for us. We should get back to the file size we had in the intermediate before the tree shaking happened. And then once this is up there, we can use a tool called the Source Map Explorer to look at the code inside of our app. So now we're back to having a vendor file that is about 485K. It's not the size we had before because now we've got much more of RxJS. I've revealed kind of where we're heading with this, but if we look at the dist folder, and I've got my files in a folder called public web, if I could type in the name of the vendor file, I put an npm script in there to run the Source Map Explorer. Let's go look at the code and show you what I'm running. There's a command here called source map explorer. You can install that with npm right here on line 10, and it'll help you explore what's in your code. And there's about 3 or 4 others that I really like using, but this is a good one. Now, you can't read all this, and nobody can, right? And I hope you don't try. But the thing you should be looking for are tiny little boxes littered all over the place. Do you see any of those? Every box represents a file. Now, let's go look inside the vendor file. What is this big thing over here? It's RxJS. And I start reading through. I'm going to zoom in a little. Go back into RxJS. If I start zooming in a little, you see expand and last and window when and throttle time. And there's a lot of operators in here that I've never heard of or used. It's showing you that because we pulled in that bigger library, there's a lot of things in here I didn't ask for. So that was my first hint when I went through this process of looking at it. Hey, why is this thing so big and so slow to load? Because it was taking 3 seconds to load on the mobile site I was looking at. It's because I had all this stuff from RxJS in my app. If we go back now and we comment that line out, which we should just delete it, because I will accidentally include it sometime later in the future. Now we can rerun this. We can use Source Map Explorer to look at it when it's done, and it would show us that RxJS is much, much smaller in the end. So the idea here is to use the tools that come out of the box at the CLI and with tools like Source Map Explorer, Webpack Bundle Analyzer is another one that we can use, because Webpack is used to build under the covers, to really help optimize our builds. So now we are ready to go to production, right? We ran this line here. We optimized our code. We explored what the output looks like so we can see indications of where I might have a problem. And then we go ahead and use that information to optimize what we have, make our changes, and redeploy. That's great. It works on my machine. How do I know what my code will work on your machine and your machine? Trust me, right? Happens all the time. So one of the things we have to do is think about how we can get it to run everywhere. What we really want to do is take our laptops and put them in the cloud. But think about all the steps we have to do locally, the things I didn't tell everybody, right? Oh, yeah, you need this version of Node. You need to run npm install. What version of npm do you have? Are you using Yarn? What kind of dependencies do you have in your project? Do you need dev dependencies or production? We got to build the Angular assets. We got to create an Express server or Nginx. Then we got to copy it all to the right folders. Hardest thing in coding, making sure your paths are right, right? Get it all in the right place. And then at the end of the day, even if you do all of that, what happens if I'm running Node 6.11 and you're running Node 8.1? Might work, it might not. What if you're running Windows and I'm running a Mac and it's running in the cloud as Linux? We have to worry about these problems. So what we really want to do is we want to automate the build and deploy process so we can have confidence that anytime we make changes, it's just going to work. Now, my good friend Dan talked about a tool in the previous talk that is really coming into its own, especially in the web community. We have so many things in JavaScript Flavor of the Week that it makes it hard to get everything to work together unless you have a repeatable process. A lot of times we create scripts with Gulp or Webpack or even Bash scripts to maintain this, but Docker containers can help us solve this problem. Dan showed us how we could use Docker to create a Docker file. It's basically a self-contained script that allows us to create a recipe to put things together to run our applications. Now, the key is also you want to make sure it's configurable to different environments. Otherwise, you run it on your machine, you don't want the same keys to be used in production. For example, in production, I want to hit a production database. On my machine, I want to hit a test database. So you have to take these things into account when we write our Docker file. This is kind of a file like Dan showed us earlier. We make sure that we can put this together, and then we can now automate it by having this. All right, so we create the Docker file. We've got that. Next step, we think about what we want to do is we want to build that Docker file and run it locally. I want to make sure it works here first. And then I want to debug it locally. I don't want to lose the ability to debug. That's like my main thing. If I can't debug my own code, we've got problems. So let's go look at a demo of how we can do that first before we can think about getting it up in the cloud. So one of the cool features that we've got inside of Visual Studio Code is there's an extension called the Azure CLI extension, which allows us, even if you don't run CLI, Azure CLI, it allows you to run bash commands effectively right here from Visual Studio Code. And you get IntelliSense on it. So I just wrote some Docker commands in here, and I can run anything. So for example, I could type ls, I hit command tick, and it just did an ls down below. That's pretty cool. So I can run commands there and see them, and I can save these files, which makes it useful for other developers to look at. So with that in mind, let's say we wanted to run that Docker file I created. We'll go look at it in a moment, but first let's build it up. I've got this Docker file. We're going to build it using a debug Docker compose. That's going to allow us, if we go look at the compose file, to run our Docker file in a node environment called development. If I go look at our Docker file, up top I'm using a multi-stage Docker file. I'm pulling in an image I created in Docker Hub, just like Dan showed Docker Hub earlier. I've got my own image of the Angular CLI running on Node. So I can just pull that down. That means I don't have to install the Angular CLI. That's great. Then I install my project. I run ng build. I could run the build optimizer as well. And then I go ahead and I grab Node, and I build my Express server on a different image. I take both of those images, called Angular and the one called Express server, and at the bottom, I create a new image, pull the files in from those two. Why am I doing this? Because I don't want all the build files and the source code from my project or from my Express stuff. I just want the resulting dist folder. I grab that, and I put it into an image. I expose my port, and I run node index. That's it. The Docker file runs that, and then my Docker compose runs it. If I go back to that file, and exposes 9229, or 5858 if you're using an older version of Node, for the debugging port. So now I've got a Docker file that can run locally. Let's go see how that worked out. If I come back down here, it looks like it built it. Well, now we can run this Docker images command right inside VS Code. Let's do that. And that's really readable, isn't it? I can't read that, can you? So it'd be really cool if there was a tool that I could use to look at, did my image get created? There's an extension that we can go look at here. And I like the icons, otherwise I lose myself. There's an extension that we could get called the Docker extension. And if we get that Docker extension, it creates a list of the local containers and images on my machine. So we can look at them over on the right, or the left. Notice in the bottom, there's a running container with a green light on it. That's the one I just built and ran. Well, you may not believe me, so check this out. I always like to see what's in my Docker container. I don't trust it. I want to make sure the files I think are supposed to be there are in there. I can right-click and do attach shell, and then over on the right, down at the bottom, I could type ls, and look, there's my node modules, my index.js for my node server. I can go look for my Angular files, which I put in the public web, and there's all the bundles that I created. Great. So I'm able to look in the shell there, but I can also check out the logs. So I right-click over here, I can show the logs on the container. Now you can see it's running my API on port 3001, and you can see Mongoose is being used. That's pretty awesome. Well, look what else I can do up inside of here. And now I can do command, and I can open up in browser. So now you're seeing on port 3001, here's the application that I just ran and built, running inside my Docker container on my machine. And if I want to debug this, I can go over to the Debug tab in Visual Studio Code, open a configuration, which this little gear is, and I can type in these commands. I give it a name, Docker attach the node. I tell it to attach on the port for debugging, 9229. And then I use the address of localhost and point to the local root, this is the important part, of where is my source code. So it's mapping the code in the container to the code on my hard drive here so I can debug locally if I want to. Now, I just have to run this. Let's go set a breakpoint. We'll go to a route file. I've got a breakpoint here on my get heroes. And if I go back to my browser and I refresh, I'm inside of the Docker container looking at the debugging. I've got a call stack, I've got everything I need to do, and I can run through it line by line. That's pretty awesome. Really easy to debug. And then I can disconnect with this little plug command. So now we feel much more comfortable about, okay, by going to Docker, I've solved the problem of wrapping up all my code in one place without losing control over what I'm doing locally. Because that was my biggest fear getting into Docker originally, is what? You mean you're going to take everything I have and put it in a container, and am I going to be able to do everything I used to be able to do? Edit files, debug files? Yes, yes we can. So now that I know it works locally, and we containerized that, we ran these commands to build the image. We could do what Dan did earlier, which is basically these commands. He wrote a Docker build file. He then tagged the image, it's giving it a name, and then he pushed it up to Docker Hub. You can use this Docker push command to get it up there. In my case, I pushed it up to Azure. But the problem here is if I push it up to an Azure container registry, which is like NPM for containers, you push it up into a registry, I am responsible for doing my builds. What happens if, Richard hits me with a truck and I'm out for a week? Please don't.
Your wife would have words with me.
Yes, she would. And then she'd be responsible for doing the build, and she would say, ain't happening. So we want to make sure that the builds happen whether I'm here or not. It's something we want to make sure everybody can do, and it just is automated and it's consistent. So that's when we get into CI/CD. And this is where you can go and you can use things like Circle CI, you can use Jenkins, Travis, CodeShip, VSTS. You pick your favorite flavor of your automation tool. I'm going to use VSTS. In this case, I'm thinking through again. I always like to step back from the technology and think, what am I trying to accomplish? I want to write my code. That's assumed. When I'm done, I want to push it to GitHub. When I push to GitHub, I want to then have a CI/CD server grab that code out of GitHub, probably with a Git hook, right? That's not so hard. Grab that code. I then want it to take that code and build it and push it to a container registry. I want it to do what I just did manually through VS Code inside of a CI tool, and then put it in a container registry, and then just put it in the cloud. Wouldn't it be great if all I had to do was git push to do that? That's my goal. Let's go try this out. So I'm inside my app here, and we've got it running locally. Now remember, I ran that command so I could run it as a debug mode. If we come back over to the Explorer, you'll see there's a Docker Compose debug and a Docker Compose. The only big difference is that I'm setting the node environment to production for Docker Compose instead of development, and I don't expose the debug ports. Well, what's really happening in my code? Let me show you the real big difference. Up here, I've got a production file for all my environment variables. My Cosmos DB name, the ports, the URLs, my secrets, all that kind of stuff is inside this file. This production mode means that I have to set like 6 or 7 environment variables to make it work. When I'm running locally, I don't want to do that. I just want to hard code them locally, put it in a gitignore file, and run it myself. So when I run it locally, it hits this development file. And I've got an example file here to show you kind of what you would do. So the debug one hits the example file, and then the production one hits the production environment. OK, that's great. So I'm going to do the production build. And I could build this locally here and push it up. But let's say we go to our production website. Here is the same site running up on Azure now under a custom domain of Secure Heroes. My Secure Heroes are up here right now. And how did it get there? This is a website running inside of Azure. You can pick any cloud you like here for this. I've got a web app, and I've got a registry. The registry is where the containers are stored. Well, if we look at that, the website itself has only a couple settings that are important. Inside the website, I'll zoom this up. You'll notice I'm telling it, use a Docker container. Which registry do you want? Azure's private registry, Docker Hub, or your own private registry? Dan chose Docker Hub earlier. I'm going to use a private one. And then I've created the registry already. It's called the Popper Container Registry. I pick the image name, that's what I built, and I give it a tag. I'm using latest as a convention. You can also use other versions too. Tags are great. We have multiple versions of the containers. And that's really it. I set those 3 up. Now I want VSTS, my CI/CD, to put it in that container registry. And then how does it get from there over to my website? That's where I go into my registry itself, which is right here. I set up my registry. There's really not much in it other than, hey, what repositories do I have? That's my image. And you'll notice down at the bottom, there's a thing called a webhook. The webhook says whenever I get the new version of the container, I set up a webhook to say, go automatically push it into Azure. Just point to the website I want it to load in. All right, cool. So the container is automatically going to move to Azure. I've solved the tail end of this. Now, in my CI/CD process, I want to have a build. And I've got a build definition here called Angular Cosmos Docker. When I click into that, these are the steps that I run. There are literally 2 steps. After I get my source code from GitHub, all I have to do is I run my docker compose command in my Docker file, and then I push it to my Azure Container Registry. I just give it the URL. Get it from GitHub, build it, push it to the ACR. How does VSTS, working backwards, know that GitHub has a change? There is a trigger in here where you just check this box. So now, when I push to GitHub, GitHub's going to let VSTS know. VSTS is going to go, OK, build my compose, push it to ACR. ACR has a webhook, which then pushes it over into Azure automatically. John, I don't believe a word you're saying. Let's look here. I've got this hero's title. Let's go into the code. I'm going to go to my app component, and I'm going to change this to heroes to Richard's heroes. We're picking on you today, Richard.
I'm okay with that.
Here's my git change. I'm going to take this now, and I'm going to save it for Richard. And then I'm going to push right here through the UI. Now, as that's pushing up, it's going to go over to GitHub. And then in GitHub, it's going to let VSTS know. We can kind of watch this as it happens. Let's refresh the screen of my build definitions here. Notice on the top, it says status of in progress for that build definition. So it picked up the Git hook saying, OK, I've got to do something. What do we want to do here? We're going to watch it. I like to watch my builds happen. It's like watching paint dry, right? Now, when you run builds normally, they can take anywhere from seconds to minutes, depending upon how many things are lined up in a queue for a CI/CD server, the hard drive speeds, whether you're using Docker or not, how many build steps you have, lots of variables, npm installs, things like that. You'll notice here, it already got the source code. Now it's running the Docker Compose, which is going out there to pull things together, to do my npm installs, which will take a little bit in here, and push things up into my Docker image and basically make it ready. And when this is done, it's going to put that over into my Azure Container Registry. So back into our source code, if we go back and look at that Docker Compose while that's building, you'll notice I just had a couple things in this YAML file. I'm not a fan of YAML, I'll tell you right away. I get the spaces wrong and everything goes to heck. But if you get your YAML stuff right, and you use a nice little tool, the Docker extension will help you actually give you IntelliSense, which is nice. You'll notice I've got one thing I'm building. It's called Angular Cosmos DB. I point to the name of the image, give the tag of latest. I'm saying build everything in this folder. That's what the dot means. And then I get that environment to production, so it knows to use the environment variables. And I've hard-coded one of the environment variables because it's not all that secure. And internally, I'm going to use the port 3001 and expose that. It's not going to matter for me. So where did those environment variables come from? Well, as it's building here, we can go back to our website. And in the website, you'll notice there's a thing called application settings. And if we scroll down, we should see a bunch of environment variables right up here. You shouldn't copy those keys down right now. These are all my production keys for my super awesome Hero site. And you'll notice I have my Twitter client and my Cosmos client and all these other fun things up here. And there's a guy in the back who set this up for me who is going to go and change the keys right after the talk. Right, Brian? Yes. So here's all the keys. That's how it's getting read into my application. If we go back to our build, now you'll notice it's on step 12 of 19. We've got about 2.5 minutes in. We're running npm install for my application. It just finished the npm install, and now it's going to wrap up actually doing the ng build for me. And once it does that build, it'll push to the ACR. And pushing to the ACR doesn't take too long, and then it'll clean up the job that it's got. So cool. As this is completing, we should then be able to go over to the Azure Container Registry and see that it hit there. And if we come over to our webhooks, we could actually click on it. And if you refresh, there'll be a date up here of, hey, when did it happen? This one just happened. It says 4 p.m. GMT, which is 12 right now. So that is the thing that got pushed. If we go over to our website, we refresh, we should be seeing Richard's Heroes. People are adding stuff. Yes, Brian Clark, you are the best. And let's see. There we go, Richard's Heroes. Pretty cool, isn't it? Now, every time I push, it goes. All right, so what did we do here? We deployed Angular to the cloud. Everybody here can do this. We're building and running locally and debugging it with Docker. Everybody can do that here. We just shown that. This app is something you can grab too and do the same steps. Just can't use my keys. Continuously build and deploying with VSTS. Not so hard to do. Does it work with other CI systems? Absolutely. In fact, you're going to see that, I think, tomorrow from Simona Koten's talk. And then you can also host it in the cloud using your preferred hosting provider. Now, I happen to like using Linux up there for my Node apps, so I use Azure App Services with Linux to do that. The big thing to take away here is the CLI is going to be something that you really want to use. You're going to optimize your bundles with this. I know a lot of folks haven't started using it yet. Please, try it out. It's amazing. You're never going to want to do your own builds again. And Docker is going to make it run everywhere. I always hear, why Docker? Everybody talks about Kubernetes and swarms and having 20,000 instances scaling up and down. That's great if you're into infrastructure, networking, and scaling. I like to write code. And when I write code, I want to make sure my code works on everybody's machines. So it runs everywhere. And without good tooling, we kind of suffer. So we want to have good tools. So here's all the links that you'll need from today. It's in the deck. We'll share. Feel free to take a picture, too. You can access all the source code from the develop branch of this GitHub repo. You can grab all the Angular extensions I'm using, plus the Docker and the Azure CLI extensions. Wonderful extensions. They came out recently. Really, really like what they're doing with it. And finally, thank you for coming to AngularMix, and I hope that you learned how to deploy and feel good about it.